All right, so here's the mixed strategy. The mixed strategy is that everyone just chooses to dare with probability 1/3.
Oh, really?
Yeah, that works out to be a Nash equilibrium. I will leave it as an exercise to the reader to convince themselves of that, but it does actually work out to be the case.
Huh. And so that means we both dare with probability 1/3, which means 2/3 of the time we chicken. So there's going to be some probability that we both chicken, some probability that I chicken and you don't, some probability that you chicken and I don't, and then the lowest probability is we both dare. Boom.
Right. So, in fact, I'm glad you said that because that's exactly how we would figure out how good a strategy this mixed strategy is.
Right.
So, let's do that. So, let me ask you a question. What's the probability that we both chicken?
4/9.
And how'd you get 4/9?
I looked at your notes. That's the problem with being in the same place when we're doing these recordings.
Well, I'm pretty impressed that you could actually read my handwriting. But
No,
sure.
I can not only not read it, but my eyes are old enough that I can't read it anyway, even if you wrote it nicely. So, no, what I did is I took, if the probability of dare is 1/3, then the probability of chicken is 2/3, and we're independently choosing that. So the probability that both of us choose it is 2/3 times 2/3, or 4/9.
So what's the probability of one person chickening and the other person daring, in particular CV?
CD, so that's 1/3 times 2/3, which is 2/9.
And by symmetry?
9 seconds. Oh, sorry, 2/9. And then dare would be 1/9 because it's dare times dare.
Right.
And let's just double check that. 4, 5, 6, 7, 8, 9. Woo! Wait, no, not 1/3. The bottom thing.
Oh, thank you so much.
Okay. Oh, and so now we can figure out from this what our expected, let's say my expected reward would be for playing this Nash equilibrium.
Right. So let's say you're player 1. So this is you. So then if we do CC, so you're the row. What is your payoff?
6.
So we can just say 6 times 4/9. What's the payoff if you chicken out and I dare?
2.
2. And what's the payoff if you dare and I chicken out?
7.
And what's the payoff if we both dare?
0.
0. So we add all that up, multiply these numbers, add them, and what do we end up with?
You're asking me?
Yeah.
You're the one who can do arithmetic.
You're right. It's 4 2/3.
Really?
Yeah, we just did that by keeping the denominator the same. So that's 24 plus 4, which is 28, plus 14, right? Which is 42, plus 0. 42 over 9 is 4 2/3. This is actually pretty cool, and the payoff is 4 2/3 on average for you. And by symmetry, it's actually 4 2/3 for
Which
me.
I like better than both of us chickening out.
Right, both of you chickening out is...
No, sorry. No, that's better. I like better than me chickening out.
Right.
And then I only get 2.
Right, and so actually doing this, even though occasionally we will, in the game we'll both die, but of course we aren't going to die, we're just going to get 0 utility because all that other stuff doesn't really matter.
Okay.
We're going to do this. This is actually pretty good, right? This is a pretty good payoff.
Okay, I agree with that.
In fact, for either one of us, if we get in the short end of the stick for the CDDC, this is actually better for us.
That's true. The worst of us, or sorry, not the worst of us, that doesn't sound right at all, but the least fortunate of us is much happier with this outcome than the CD.
Right, and by the way, we're actually happier with this outcome than if we had uniformly randomly chosen between them.
And we're better off with this outcome than if we had done CD and then split the winnings, which would be 4.5.
Yeah, so it's the same thing as doing half,
Okay.
multiplied by half, right? It's 4.5. 4.5 is less than 4 2/3. So right, those are in fact the same thing in this case.
Got it.
This is why it's something like 1/3 and not something like a half. So that's pretty cool. So this seems like a pretty good win, but I'm going to claim that we can do better.
Okay.
Okay. So let's remember this 4 2/3 and keep it around for a little while, and let me try to convince you that we're going to do better. Okay?
Okay.